All right. So I have a physics background. And that's how I came into math. I was actually, for the first semester in college, an engineer, and I got bored with it. Wasn't going to be my thing. I have a minor in math, but I've always enjoyed math. So I've taught myself reading books, a lot of stuff, because I find it fascinating. But this is a typical physics application because a lot of motors are rotary, and there's computers that we program to make the motors do things. And when we program those computers to make the motors do things, we're going to use trig functions. Okay. So what we want is we want this gear to rotate 6 revolutions a second. That's what we want the computer to tell the motor to do. And in the computer program is going to be this function. So in order to make that happen, we got to figure out how to model this, and then we can do that. All right, so this gear's got a 5-foot radius, and we want it to rotate 6 revolutions per second. And we're just going to simplify the problem. We're going to rotate in the positive direction. Okay, so the y coordinate would be modeled by the sine. And since the radius is 5, then we will get 0, and then 5, and then 0, and then -5. So that means the amplitude is 5. So we already know the amplitude is 5. It's the same as the radius. Okay, but the thing is, what we got to do is figure out how to make the k model the rate of speed that's going to cause this to go 6 revolutions in a second. All right, so let's find out what 1 revolution is. Because remember, 1 revolution is 2 pi radians. Okay, so if we wanted to find out what 1 revolution is, I'm going to multiply top and bottom of 6 over 1 by 1/6. And so you get 1 revolution in 1/6 of a second. Now, if you know that little trick that I can do mentally doesn't work for you, what you could do is solve, okay, well, what would that be if it's 1 revolution per second? And notice when you do this, you'll get 1/6. So you could also do that. All right, so we want 1 revolution in 1/6 seconds. That means we want 2 pi radians in 1/6 second. Okay, now remember, when this becomes the sine of 2 pi, or 4 pi, or 6 pi, or 8 pi, that's 1 revolution. And we want that to happen for 2 pi when the time is 1/6 of a second. So we want to get 2 pi, which is 1 revolution, when the time is 1/6 of a second. So we will solve. Oh, wait, let me not jump to that just yet. So this is what we're using. When did we get 2 pi? Well, what happened when the time was 1/6? Okay, so now we can figure out the k that would model this problem, multiplying by 6. Okay, so then 12 pi. I think someone just got here. All righty. Okay, so now we can go ahead and just plug that in. We already knew that the amplitude was 5, since if the radius is 5, the y value as you go around is going to go 0, 5, 0, -5. And then we need to figure out what the k would be to get the sine of 2 pi, which would be 1 revolution. And so I went ahead and changed 6 revolutions per second to figure out what 1 revolution is. And I did that fractional shortcut, or you could just solve this problem. If 6 revs per 1 second, what would 1 rev be? Okay, so when we solve this problem to figure out k, we want this to equal 2 pi, 1 revolution, when the time is 1/6. And so that means to model this motor, we're going to have to use y equals 5 sine 12 pi times t. So that's the answer. But, you know, a lot of times it's a good idea to test things or just to kind of look at it another way. So I'm going to go ahead and make a table. So we've got the revolutions. So the first revolution, the second revolution, the third revolution, and so forth. Now, each revolution occurs in 1/6 seconds. So one revolution would occur in 1/6 seconds. The second revolution would occur in 2/6 of a second. And the third revolution would occur in 3/6 of a second. So just to look at this another way, here's the model. Now it does work, but I just think sometimes it's good to look at the house from the back door instead of the front door. Give you a different perspective. Okay, so let's see what 12 pi t would occur. All right, so if you put 1/6 in, 12 pi over 6, well, that's 2 pi. Okay, so that checks. That should, because that's one revolution. Now this is really 1/3. So if you put 1/3 in, that becomes 4 pi. That's the second revolution. All right, so this appears to be working. And then when you put 1/2 in, that's 6 pi. So every 1/6 of a second, we get the sign of 2 pi, the sign of 4 pi, the sign of 6 pi, and then that's so forth. So just to look at it another way. So that's the model, and that's what we would program in the computer to tell the engine to turn 6 revolutions per second. It's pretty fast. All right, so I'll wait a moment, and today we're going to look at the cosine graph and also something called vertical displacement. And what a negative period means. Now, when I did this, I just modeled it going in the positive direction. If you wanted to model this going in the negative direction, you would just make this negative 12 pi t. Because as time goes forward, then positive numbers multiply to a negative, which means a negative angle in the sine function. So that's all you'd have to do if you wanted to model rotating in the other direction.